Hello everyone and welcome to another video presentation for the course Immersive Experiences and Technologies offered by the Democritus University of Thrace. Today I will be sharing my review of a virtual reality platform called Spatial IO. Before we begin, here is a quick overview of what we will cover today. First, I will introduce you to Spatial IO for those who may not be familiar with it. Then we will explore the possibilities it offers to educators as well as some of its limitations. I will also share my personal recommendations based on my personal experience as an EFL teacher on how this VR tool can be used in the classroom to make lessons more effective and more engaging. Finally, we will wrap up with some well rounded conclusions about spatial and its potential in education. Let's dive in. So, Spatial IO is an online VR platform designed for interactive and collaborative learning. It works across multiple devices such as smartphones, tablets, and VR headsets, and can be accessed directly through web browsers using WebXR, as Hidayati et al. Explained in 2024. As Durmaz in 2024 highlights, Spatial IO offers an accessible user interface with a variety of features for both hosts and participants, including a chat box, voice chat, screen sharing, and interactive gestures. It also provides extensive documentation to help developers explore its capabilities and create new virtual spaces for the community. Another advantage is its integration with Sketchfab, with users having access to a large library of 3D assets that can be uploaded directly into spaces without the need for external applications. Research also highlights the educational potential of platforms like Spatial. For example, Busajari et al. In 2024 found that learning in the metaverse can significantly boost students' engagement. Hidayati et al. In 2024 add that such platforms help improve students' digital literacy as they learn to create avatars and build virtual environments. In addition, participating in these spaces can enhance their autonomy and their motivation while allowing teachers to deliver more individualized instruction to meet diverse learning needs. Again, as Busajari explained. Together, these factors lead to richer, more interactive, and more meaningful learning experiences. Now, as with any technology, it's not all smooth sailing. VR platforms like Spatial IO are exciting, but they are not quite classroom ready yet. As Sriwarapong et al. In 2022 note, usability and user experience still need improvement, and technical demands such as heavy graphics and battery drain can make it difficult for students to use them effectively in the classroom. Accessibility is another big issue. Fusion in 2022, as cited in Hidayati et al. In 2024, explains that to fully experience the metaverse, students need compatible devices such as VR headsets, which can be expensive and not widely available, as well as fast, stable internet connection. These requirements can limit access, especially for learners from lower socioeconomic backgrounds. There are also platform specific limitations. For example, in the free version of Spatial IO, only one host can manage the space. To have multiple hosts, you need a paid subscription, which can be a barrier for organizing larger events. The Spatial I/O Toolkit is another challenge for known coders as it requires familiarity with the Unity game engine, visual scripting, and some basic programming skills, as Durmaz in 2024 highlights. Finally, another challenge is the age gap between teachers and students, which can make it harder to bring VR into the classroom. Older teachers might struggle to adapt to the new technology and to work with students who are already very comfortable in digital environments. There is also no single set of rules for how VR should be used in education, which means the materials created for one school might not work easily in another. This can make it harder to share resources and keep quality consistent, according to Ledge and Boner in 2020, Velev and Slateva in 2017, as cited in Durmaz in 2024. So, while there are some clear hurdles to using spatial I/O in education, none of them are deal breakers. With the right planning and support, these challenges can be managed and, in many cases, turned into opportunities for creativity. Let me share how I believe spatial I/O can be used effectively in the EFL classroom. As an EFL teacher, I see spatial I/O as a powerful tool for creating immersive and language rich environments. One practical way to use it is by designing virtual tours where students can explore landmarks, interact with 3D objects, and read short texts linked to what they see. These tours could be followed by a pair or group discussions inside the virtual space, helping students practice speaking in a realistic contextualized setting. Another idea I would suggest is to use Spatial I/O as a collaborative project hub. For example, students could work together to design their own exhibitions, adding images, videos, and text descriptions in English. This not only develops their language skills, but also fosters their creativity, their teamwork, and their digital literacy. Of course, to make the most of spatial I/O, it's important to provide guidance and support, especially for those less familiar with VR platforms. Starting small with simple activities and uh, teachers making sure that they gradually build confidence before moving on to more complex projects. In conclusion, spatial I/O offers exciting potential for creating immersive and engaging learning experiences. While there are still technical accessibility and adoption challenges to overcome, its potential for fostering collaboration, creativity, language development, autonomy is undeniable. With thoughtful planning and gradual integration, it can become a valuable addition to the modern classroom. You can find a list of references at the end of this presentation. Thank you so much for watching.